All right, guys. So we're gonna finish up with the quiz, Circles Quiz 2. There are still some of us that have a couple of questions remaining from their personal Khan Academy profile. So we're gonna get through that during today's session, and hopefully, maybe we can move on to the remaining Khan Academy assignment. Okay. So,
I
Michael,
got it
you ready?
in. Yep.
You got it?
Yep. Got it in.
Okay. So you're going to present your screen.
Sure. Do you not see it?
I see it. Okay, so let's see. So you're given something in degrees and asked to convert it to radians. Michael, do you remember what was the formula that we have to use to accomplish this?
It's the Theta theory, right?
No, the formula.
Pi over 360 equals arc length over circumference.
That is true, and using a proportion, okay, you can sort of accomplish this, but there was a more direct equation that you can use to convert something from degrees into radians. Do you remember what that was? If you don't remember, I can remind you.
Just remind me.
Okay. So, and actually, I think this would be a good opportunity just to recap everything. So, right now, up to this point, okay, one more time for everybody's review and purpose, okay? So theta, okay, is an angle in degrees, right? And beta is an angle in radians. Okay, so these things, okay, they mean the same exact things. It's just that one is expressed in this unit of degrees and the other is expressed in a unit of radians. Okay, they both describe angles. Okay, they both describe angles. All right, so there's a direct conversion, okay, that can happen. Beta is equal to, Emma, do you remember what that is? No, the conversion, going from theta to beta.
Oh, it's like converting it to, it would be 180 over pi.
The other way around. So it's theta times pi over 180. Okay, so that's direct conversion. This is the conversion going from theta to beta, okay? So convert from degree to radian. And Michael, if you don't remember this, I highly encourage you to write this down, all right?
So I now remember that. Yeah, I remember that formula.
Okay, so convert from degree to radian. Okay, so this is an important one. And then there was also this concept of finding out what figuring out arc length, right? So we started off, okay, this whole idea of figuring out what arc length was by doing a proportion, right? Theta over 360 is equal to arc length. Oh, actually, I'm going to use the letter S because Khan Academy here uses the letter S, okay? So S is equal to arc length.
That was what I said earlier, was it not?
You were hinting at this, okay? But my question to you in the very beginning was, what was the formula to convert from degrees to radians?
Now remember, okay. Theta times pi is equal to 180.
Right, that's what I have boxed in there, okay? So now there's this way that we can find out what the arc length is, okay? by saying theta over 360 is equal to S over C, okay? And I want to say C here is equal to the circumference. And Michael, what's the circumference formula?
What's the circumference formula?
Right.
Is it what I said earlier?
How do you find the perimeter of a circle?
2 pi
2 pi
r.
r. There you go. Okay, so the circumference is 2 pi r. Okay, so we can find there is this proportion that we can set up. Theta over 360 is equal to the arc length over circumference. Another thing that we can use, okay, and we sort of used this yesterday, is, you know, beta over, so instead of using 360, a full circle going around the circle, one revolution, okay, going around the circle once, okay, in degrees is 360, but what is it in radians?
2 pi radians.
It's just 2 pi, that's right. So alternatively, okay, we can actually use this, S over C again. So this is the proportion for finding arc length. This is the proportion for finding arc length, okay? And then what we did was the following, okay? We then did a conversion, okay? That this then turns into, this then turns into, well, we can actually do this. We can say the arc length, okay, if we do if we want to write out the formula directly, is equal to theta pi over 180 times the radius. We did that conversion, or we did that. I showed you that derivation. I think it was on either Monday or Tuesday, okay? And then there's a second formula, because we can express this, okay, not just in terms of the degree measure, but also in terms of the radian measure, okay? So we can find out the arc length using this method here.
Cool.
Okay, so there are two different formulas, okay, that you need to be familiar with, okay? One for finding out arc length in terms of like using if you're given something in degrees, and the other is for if you're given something in radians. So this right here, okay, is arc length formula. That's the arc length formula.
Get it.
And then yesterday, okay, we talked about something known as the sector of a circle. Okay, so the sector of a circle, and the sector of a circle, I want to call A the sector of a circle. Do you remember what a sector of a circle was?
A part of a circle, or a slice.
It's a slice of the circle. That's right. When we talk about the slice of the circle, are we talking about like the perimeter, or are we talking about the area?
The area.
Yeah, that's right. So a sector of a circle is the area for a quote-unquote slice of a circle. And it was achieved, okay, in a very similar manner, okay, through a set of proportions. And I'm going to write that over here underneath the proportion for arc length, because it coincides with it. So theta over 360 should equal to, I'm going to use the letter A for the area of the sector, right? What's the area for what's the area of a circle again? How do I find that out?
Pi over 360 equals arc length over circumference.
No. The area of a circle. What's the area of a circle? Pi r squared. So over pi r squared. right?
Oh yeah.
So we can set up this proportion, okay, in this manner involving degrees, and the alternative is we can also do this using radians. So it's beta over 2 pi is equal to k over pi r squared. Okay, and what I'm doing over here, this is proportion for finding sectors. That was sort of established, I think it was on Tuesday, okay, when this idea of a sector was first introduced, okay? And then from here, okay, we can then generate a formula that's a little more direct. So the formula, okay, that we can that can come out of this, okay, that is a little more direct, looks something like this. And this was derived, I think it was on Tuesday or maybe Wednesday. So it's 1/2 theta pi over 180 times r squared, or 1/2 beta r squared. Okay, and this right here is to find the area of a sector. Okay, so this right here are all the formulas that was achieved last week and this week. Okay, so if I were you, I would take a screenshot of this, or definitely have this written down somewhere. Okay, Michael, you have it?
Yep, got it.
Wait, can you move over a little bit to the left?
A little
It's like
over to
a little
the
blocked
left.
out. No, to the right. Like the left
is that better
part is
now?
cut off a little bit.
I can't move. I can't show the left side of the page anymore because I'm already like really far in. Like I'm on the extreme left already. You guys have this?
Yep, I have it.
Okay.
Oh wait, this is better.
Okay.
Wait, this
Kelvin,
is
you
better.
have it?
Yes.
Okay. Kian, you have it? All right. So again,
Got it.
screen right here, okay? This are all the formulas we've talked about last week and this week, okay? All right. Everyone have it? All right. So what are we going to do with this? I'm going to stop presenting. And we're going to look at, again, Michael's presentation here. Okay. So his question right now is, you're given something in degrees and you're asked to find out what it is in radians. You're asked to convert 290 degrees to radians. Well, we have all the tools that we need now, okay? Michael, what do we do? Tell us what to substitute in.
Convert the angle theta equals 290 degrees to radians.
Which formula are you going to use?
We use the conversion formula for degrees to radians.
Good. So tell us what's a substitute.
Okay, the substitution's a little hard. Is it 290 pi over 180?
That's exactly it. 290 pi over 180. And actually, technically, okay, if you input that in, okay, without having to simplify, that's technically the answer. But you are allowed to, I mean, you should simplify because there's a common factor of 290 and 180, right? What's the common factor?
10.
10. So what's another way of writing 290 pi over 180?
29 pi over 18.
That's it. So you're going to enter that in.
Got it. I'll do it right now. My computer sometimes it's a little buggy. It's slow sometimes. Got it.
Okay. All right. Next. So
A circle.
here you're given that the radius of a circle is 10 and has a sector with a central angle with 2/5 pi radians. And you're asked to find what is the area of the sector. Okay. So again, the radius is 10. The central angle is 2/5 pi. Okay. So I'm going to show my screen again.
No problem.
So which formula are you going to use here now? So I want to number these so that we can quickly reference this together. So I want to call this like, box 1. Whoops. I want to call this guy right here box number 1, box number 2, box number 3, 4, and 5. Okay. Which formula are you going to use?
A equals 1/2 beta r squared, since it's saying radians.
Exactly. So in that formula that you just pointed out for us, what do we know?
The radius is 10.
Yep.
The central angle is 2/5 pi.
Is that A or is that beta then?
Beta.
That is beta. So 1/2 2/5 pi times 10 squared. What do we do to simplify that?
We can cross multiply.
No. What's 1/2 times 2/5?
4/5.
No. So you see here, the numerator here has a 2, the denominator has a 2. When you're multiplying them together, they are the same things, both numerator and denominator. What happens?
It's still 2, or it becomes 4.
It cancels. 2 over 2 is, what's 2 over 2?
1.
It's 1. There you go. So this becomes 1/5 pi times 10 squared, right? Well, what is 10 squared?
100.
So this becomes 1/5 pi times 100. Wait, how many times does 5 go into 100?
20.
That's it.
20 pi.
Okay.
Right. Got it. Okay, resume presentation.
You don't need to press resume presentation because you're still presenting.
Oh, okay.
Okay, because you didn't stop presenting, but it's okay. All right. So an arc subtends a central angle measuring 7 pi over 4 radians. What fraction of the circumference is this arc? Okay, so this one, okay, requires a little bit. Well, actually, it doesn't require that much more thought, but look, check this out, okay? So you're given this problem right now. You're given the central angle, which is 7 pi over 4. You're not told what the radius is. You're just asked, what is the fraction of the arc length compared to the entire circle? So I'm going to, again, just show that screen one more time. Which formula are you going to use?
Let me.
And actually, the best way to think about this, in my opinion, okay, is to not think of it formulaically, okay, but think about it logically, which is what boxes 2 and 4 are, kind of, okay. And when I think of it, and when I say think of it logically, okay, instead of formulaically, the logic here is to set up a proportion, okay. So between those two, which should you use?
So the options are boxes 2 and 4, right?
Yeah, that's true. But what would make most sense?
4.
It would actually be 2, because they're asking about the fraction of the arc length. Okay.
Oh, okay, got it.
So for this problem, yes, you are using box number 2, but I would encourage you to not think of this in terms of that formula there, okay? But rather think of it in terms of setting up a proportion, okay? So what's the central angle in this problem again, Michael?
7 pi over 4.
7 pi over 4. What's the radian measure of a full circle going all the way around?
2 pi.
2 pi. They're asking you to determine what is the fraction of the arc length to the entire circumference. Wait a minute. Isn't that what this is?
Yeah.
Yeah. Arc length over circumference is equal to this thing right here. So all you got to do is just try to simplify that, okay? So again, let's not be afraid of fractions here, okay? So I have 7 pi over 4. When you're dividing by another fraction, what do? You multiply by what?
Numerator and denominator.
The reciprocal. So this is going to be 1 over how much?
Pi. 2 pi.
2 pi. That's all it is,
And
okay?
then the pi's cancel out.
The pi's do indeed cancel. They cancel. And Emmett, what is the final answer?
Final answer is 7 over 8.
That's it. That's the fraction that they're looking for. What is the fraction of the arc length to the circumference? Cool?
Okay, 7/8, right?
Yes, that's it.
All right, three down, 2 to go.
Okay.
Do you see what I'm presenting?
Convert the angle 5 pi over 12 radians to degrees. Okay. So now, 5 pi over 12, we're going to try to convert this into degrees. Let's look at this again. What formula are you going to be using?
The first formula in box 1.
The first formula, box 1, I totally agree. In box 1 here, what do we know?
Beta equals theta times pi over 180.
That's true, but what is known in this equation for this problem?
Theta, 5 pi over 12.
So one more time, is 5 pi over 12 beta or theta?
Theta.
It's beta.
Oh, it says in the problem it's theta.
No.
It was, okay.
No, it's okay. In the problem description, they gave you the symbol. It says theta is equal to 5 pi over 12, right? But is that a measure in degree or is it in radian?
Radian.
Radian. In this formula here, Michael, is beta a radian measure or is that a degree measure?
Degree.
One more time. This thing right here that I'm highlighting right now, is that a degree measure or is that a radian measure?
Radian.
That's a radian measure. And the number that they gave you in the problem that you're looking at, is that a degree measure or a radian measure?
Radian measure.
So therefore, that number that they gave you, is that beta or is that theta?
Beta.
That is beta. Okay, so I'm going to scoot over here now. So 5 pi over 12, that is beta. And you're asked to figure out what now again?
Converted to degrees.
Converted to degrees. So in other words, what are you looking for? Are you looking for theta or are you looking for beta?
Theta.
You're looking for theta. There you go. So 5 pi over 12 is beta, and that is equal to theta pi over 180. You're looking for theta in that relationship.
Mm-hmm.
What happens if you have the same things on both sides of the equal symbol there? And they're being multiplied?
Reciprocal.
No.
Cross multiplication.
Well, I'm asking the simplification question here. So the pi here, what happens?
Cancel out.
They cancel. Okay. And then yes, let's cross multiply like what Michael and Emmett are saying. So we're going to cross multiply. Okay. I'm just going to multiply the 180 over to the other side. I'm not going to multiply the right hand side by 12. Okay. So I'm going to end up with 180 times 5 over 12 is equal to theta. Michael, what is that?
Simplify it as much as we can.
Say that again.
4,500.
No, it's 900. 900 over 12.
Okay.
Oh, right.
So what is that? 900 over 12.
Oh.
It would be 75 over 12, which further simplifies into
Wait.
25 over 4.
What?
It's 900 over 12 simplifies into 75 over 12 into
No.
over
900.
No, you could simplify it into 75 over 12.
Yeah, 900. So it's 900 over 12. What's 900 divided by 12?
75.
That's it. It's just 75.
Oh yeah, you're right. It's just 75.
Okay.
Let me just put it in my computer. Stupidly slow sometimes. All right, last one.
The last one.
Yep. And the others can go.
Last one. So it says a circle with area of 81 pi has a sector with a central angle of 120. A circle with area of 81 pi has a sector with a central angle of 120. What is the area of the sector? So you're asked to find out what is the area of the sector, and you're given the area of the circle as well as the central angle there. Okay, so now that we know this, okay, I'm going to, again, pop back to the tablet. Whoops. Hold on. So I'm back over here. Which formula are we going to be using, guys?
Area of a sector. The fifth box, A equals 1/2 pi theta pi over 180 times r squared.
I'll give you that. I mean, you can. It is possible, okay, for us to use box number 5 to answer this question. However, it is best to think of this as a proportion problem. Just because if you think of it as a proportion problem, you will there's less algebra involved. Okay.
Yeah, you could just make it x over 81 pi equals 1/3.
Right.
Really? That's fast.
Yeah. If you think about it as a proportion problem, you don't even have to, work with any of those formulas. So one more time, the area of the circle was how much again?
81 pi.
It was 81 pi. So the area of the circle is 81 pi. And the angle is 120, was it?
Yep.
Yeah, but you could just make it 1/3.
So 120 over 360, that's where you got the 1/3 from, right?
Yep.
Is equal to the area of the sector, which actually I'm going to call, x, like Emmett had used, because that's what we're looking for, over A, which is 81 pi, right? Because the central angle and the overall angle of the circle there, it's going to be proportional. Okay, so that's the proportion that we can set up. So 1/3 is equal to x over 81 pi. Michael, what is that?
Do we cross multiply? 1/3 equals x. So it's 3x equals 81 pi.
Right, or x is equal to?
27 pi.
Yeah, 27 pi. Got it.
Yeah. That's all it is.
All done.
All right. Is there anybody else out there that needs questions to be answered?
Yeah, I have a couple.
Okay, go ahead, Preston.
All right. Hold on. Let me share my screen.
Michael, you can stop sharing your screen now. And he walked away. Okay, let's take a look. So what is the measure of theta in radians? You're given that the radius is 8, and you are given that the arc length here is 8 pi, I'm assuming.
Yeah.
Okay. So so again, like I was telling everyone, okay, you we have all these formulas, okay, that we've worked with, okay, in the past week to 2 weeks, okay?
Right.
Again, you're given the arc length, which is 8 pi. That's S, right? And you're given the radius, which is 8. And you're asked to find out what theta is. Which formula are you going to use? Or you're asked to find out what the central angle is. Based on those two givens there, which formulas are you going to use? Are you going to use the formula for arc length? Are you going to use the formula for sector? Or are you going to use what are you going to use?
Would it be the one to solve for like central angle or?
Well, looking at just the givens right now, okay?
Okay.
The information that you're given, that S is equal to 8 pi. Is that an area of a sector or is that arc length?
Arc length.
That's arc length. So that narrows things down to perhaps just these two boxes here, right? Because one box is working with arc length and the other is working with sector. Which one are we going to be using?
Arc length.
Arc length. That's it. Okay. So we're going to be using this. Okay. Does it say in the problem to use the to find the central angle in radian or degree?
Radians.
In radians. So which formula within that box are you going to be using?
S equals beta R.
That's it. So we're going to find out what beta is. Okay. So wait a minute. If we know that S is equal to 8 pi, and we're trying to find out what beta is, do we know what R is?
8.
It's 8. What would beta have to equal to?
Pi.
That's it. That's all it is. Okay,
So I mean, that's the final answer then.
that's the final answer. That is indeed the final answer.
All right. Thank you.
Wait, is that English that you have opened up?
Are you talking about me?
I see here Japan, Japanese, the Mid East. Oh, that's global.
Yeah. I am
Oh,
sorry.
that's you. Okay, so
That's
stop,
what you see. Yeah.
stop presenting. Yeah,
Oh, that's what you see. Okay.
yeah.
Sorry. I thought I'm not screen sharing anymore.
Uh,
Now you don't see it anymore?
no.
Good.
And this right here is Preston. Is that right?
Yep. It's Preston.
Okay. Okay.
Yeah.
So a circle with area of 16 pi has a sector with a central angle of 8/5 pi radians. So Preston, again, which formulas are you going to be using from what I've talked about today? Are you going to use box 1, 2, 3, 4, or 5?
Well, the formula, since we're finding a area of a sector, we should probably use box 4.
Box 4. I love that. Okay, because you can actually set up a proportion and then find out the area of the sector that way. I love that. Okay, so you're going to set up the proportion. You're going to write, well, 8/5 pi. What is that?
What do you like?
Like, is that beta or is that A?
Oh,
What is 8/5 pi in the formula that you just pointed out to us in box number 4?
oh, I see what you mean. That would be beta.
That would be beta. So 8/5 pi, you're gonna write. You're gonna write. Hold on. You're gonna write 8/5 pi over 2 pi is equal to, what's the area of the circle again?
Oh, the circle? 16 pi.
It was 16 pi. And you're trying to find out what the area of the sector is.
Yeah.
That's all it is, okay? And right now, this is just a matter of you being confident with simplifying fractions, okay?
Okay.
So notice here I have pi and pi. What happens?
Oh, those cancel out.
Those cancel out. And then I have 8/5 divided by 2, right?
Right.
When you're dividing fractions, what happens? What do you do with the fractions?
You multiply them.
Multiply by what?
The reciprocal.
Which is 1/2, which is a over 16 pi over here. Okay. How many times is 2 going to 8?
It's 4.
So it's 4/5.
Yeah.
And then what do we do with the 16 pi there? What are you going to multiply that with?
4.
You're going to multiply with 4. So a is equal to 64 pi over 5. That's all it is.
Okay.
Okay. Let's stop presenting here. All right. 180 degrees to radians. What do we do there?
Oh, that one's so easy.
You can do that really quickly in your head. What is that?
Is that just 1/2 pi?
That is not 1/2.
Oh, yeah, no, not 1/2. Sorry.
Pi.
It's just pi.
Yeah.
Isn't it just pi?
Because it's again, the formula was theta pi over 180, right? You're replacing theta with 180. So
Sure, I think I was thinking of 360 or no, 90.
So in this case here, what is the length of arc S shown below? Okay, in this case, okay, what formula are you going to use? Box 1, 2, 3, or 4?
To find arc length, it's a box 2.
Box 2. Which formula specifically in box 2?
Theta over 360 equals S over C. Or sorry, S over, yeah.
You can use that, yes. Actually, yeah, if you want to continue using that, you can. You can also actually directly apply the formula in box 3, but whichever, okay, it's all the same. Yeah. What's your final answer if you apply the formula in box 2?
Hold on, wait. It would be pi over 4 over 360 equals S over, or wait, no.
It would be pi over 4 divided by 2 pi is equal to S over
2.
the circumference.
Oh, the whole circumference, sorry, wait.
Yeah. Preston, I'm actually gonna encourage you for this problem just because if you know the formula, it takes like 5 seconds. Okay.
Right.
If you look at box number 3, okay,
Right.
box number 3, okay, you're given the arc length is equal to
Beta times R. So I guess just so it would be S equals pi over 4 equals times 2.
That's it. So pi over 4 times 2, what is that?
Pi over 4 times 2 would be, oh wait. Wait, hold on.
No problem. When you're multiplying fractions, you're multiplying across, right?
Right, so it's times,
So it's 2 pi over 4, but you can reduce that, right?
Yeah, you can reduce that to pi over 2.
That's it. You got it.
Okay, sorry, yeah.
No problem. Awesome.
Thank you.
That's it. That's all there is.
Yeah.
Okay. Is there anybody else that needs additional help with the problems from the quiz? Calvin, you're done. Okay. Kian, you're done.
Emmett, what about you?
I'm done.
Okay.
Everyone good?
Yeah.
All right. So we're kind of running low on time here. I'm gonna hold off on that last exercise for tomorrow then. Okay.
What last exercise? Is it like
there's one additional exercise. Let me just do a present screen to let you all know.
Okay.
Let me see here.
It's a perfect fit for tomorrow then, the end of the week. I'm so excited for Memorial Day. Hooray!
Yeah, me too. Okay, so we just finished Circles Quiz 2. We have inscribed angles for tomorrow. Okay? This guy right.
Okay. We just took notes on that video yesterday, right?
Yes. No. Well, if you did it yesterday, then yes.
Okay.
Yeah.
I did it yesterday.
Okay, cool. All right. So I'm gonna stop here, okay? And I'm gonna hit stop recording.